Now when building out a program, you want to try to include as much control as possible. And one way of doing this as a Python developer is to throw an exception if a certain condition occurs. Now to raise an exception, we can use what is known as the raise keyword. So as an example, if I first of all set a variable to equal the string 30, let's suppose I have a conditional statement that checks to make sure that the age variable contains an integer only. So I could put if not, and then the built-in type function and pass in the age variable is int. So let's just think about this for a second. If the age is an integer, then it would come back as false and the following code would not be executed. But if the age variable contains something other than an integer, this would flag as true, and then we would run the following statement. After the int keyword, I can then put a colon, and then at this point we can raise an error. So I can put the keyword raise, and then I can raise the error that I want. So in this example, I will raise a type error. Now inside the parentheses, I can then also provide a message that I want displayed on the screen. And you've seen these messages in the built-in exceptions, but this time we're creating our own message. So let's put the message sorry, comma, only integers are allowed, exclamation mark. If I now run this code cell, you can see that we run into a type error, and the message is exactly what we want it to be, to provide the user a little bit more guidance as to what error they've run into. So how could we apply this to something that we've seen before? Well, let's create the play again function, which asks a player whether they want to play the game again or not. So we can define our function called play_again. We can then put parentheses and a colon. We can then set a variable called replay and set this equal to the input function where we ask, do you want to play again? Question mark, colon, followed by a space. Now, if the variable replay, which would contain a string object, dot lower, so lowercase of this string, is not in the list which contains yes and no, then we want to raise a value error. And the message that we pass into the parentheses could be something like enter yes or no only. So when we call the play again function, we'll first of all be asked for input. If the input isn't the string yes or no, then we will raise the value error stating that they should only enter yes or no only. So let's see this in action. You can see that when we call upon the play_again function, we're first of all asked, do you want to play again? So let's just say we misspelt the word yes and we put tes. You can see that we run into the value error telling us to enter yes or no only. If I call upon the play_again function again, we're once again asked, do you want to play again? If this time I spell it correctly, so yes, you can see that we no longer run into this value error because our conditional statement evaluates to false, because yes is in that list of two strings yes and no. Great. Now we know that running into these errors will actually stop our program from running. No other code beneath it would run if we run into an error. So the way we handle this is by using our try except block. So I could do something like try colon and then call upon the play_again function. And if the user enters in something other than yes or no, we can now capture this value error because we know we'd be raising a value error, and I could put except value error colon, and then I could print to the screen a message that provides the user more guidance. So I could print something like, you should only enter yes or no in the input box, comma, please try again, full stop. And then after this print statement, because at this point they have entered in something incorrectly, I can call upon the play_again function. So let's now execute this code cell to see how it performs. Do you want to play again? Let's be polite and put no thanks. You can see that when I put no thanks, we then get printed to the screen. You should only enter yes or no in the input box. Please try again. This is very useful. Okay, do you want to play again? So I'll put no. When I put no, the code runs accordingly and we don't run into an error. So what we've done here is we've raised a value error inside of our function, but we then try to call upon the play again function and we then capture that value error and print something more useful to the screen for the user and then call upon the function. This way our program will not stop executing and it will move on to the next line of code in the script. Now so far we've seen two examples where we're raising a type error and a value error, which are built-in exceptions. They're predefined. But we can actually create our own user-defined exceptions that are more bespoke to the program that we're working with. And the way we create a user-defined exception is by writing the following. We first of all need to write a new class. So we can start with the keyword class, and then we can give our exception a name. So for this example, I'm just going to put user-defined exception. Now for these custom exceptions, we need to inherit from the exception class. So inside parentheses, we can put exception. And then we can define a very simple init method, which will initialize the object of the new class when it's called upon. So we can put def dunder init dunder, we'll pass in the first parameter as self, and then we'll pass in a second parameter as message. And then we can put self.message equals message, which will be our instance variable when we create an instance of this object. Okay, so a very simple user-defined exception class. We can now use this class in our code. So if I first of all set a variable called marks and set this equal to the integer 35, I could then print to the screen, your marks are, then a colon and a space. I can then concatenate a string representation of the integer that's stored in marks, i.e. the number 35. I can now have a conditional statement that checks to see if marks is less than 36. Then I want to raise the user-defined exception, and inside this user-defined exception we know it takes an argument that relates to the message, i.e. the instance attribute called message, and we can pass in the message, you didn't get enough marks, exclamation mark. So you can now see that when I run this code cell, it first of all prints your marks are 35, and then we get a traceback. We get told that we have a user-defined exception, and it's our own user-defined exception, and it tells us that you didn't get enough marks because we got 35, and the exception is raised if marks are less than 36. Now because we don't want our program to stop necessarily, we can handle this exception by putting it in a try and except block. So we'll first of all try and then put a colon, and we'll set a variable called marks to equal an input function which asks how many marks did you get, question mark, colon, and then a space. And because we want this to be stored as an integer, we can also then wrap this in the built-in int function. After this, we'll then print you scored with a space. We will then concatenate and pass in the variable marks into the built-in str function, and then we will plus a string with a space and then marks. Also within this try block, we will then check to see if marks is less than 36. If it is, then we want to raise the user-defined exception, so we'll call upon this class that we created, and we'll pass into the brackets, you didn't get enough marks, exclamation mark. Now, if we do run into this user-defined exception, let's state how we would like to handle this. So we can put the keyword except, and then we'll put user-defined exception. But this time we're just going to alias this to different characters to make it easier to reference later in our code. So we'll call this as ERR. So we can now use the letters ERR, which I'm using as a shorthand for error in our code, to replace user-defined exception. After ERR I can then put a colon, and then I'm going to print the instance attribute. So I can now print and then open the parentheses. I can then put ERR, which is an alias for user defined exception. I can then place a dot and I can access the instance attribute, in this case message. If there was no exception raised as part of the try statement, well then we can have an else block execute. So at the end I can put else with a colon, and I will simply print congratulations, you passed the exam, because at this point we know that the marks would have had to have been 36 or more. So if I run the code cell, you can see that we're asked, how many marks did you get? So in this first example, let's put 25. You can see that when we put 25, we print to the screen, you scored 25 marks, and that's part of the try block. We print that first before doing our conditional statement, and we then print, you didn't get enough marks. And this is because when that conditional statement is checked, it raises that user-defined exception where we then pass in the message, you didn't get enough marks, and that becomes the instance attribute. We then handle user-defined exceptions in the except block, and we print out the instance attribute message. So we get you didn't get enough marks. If I rerun the code cell, we're once again asked how many marks did you get. This time, let's put in 50. We're then told you scored 50 marks, and we get the message, congratulations, you passed the exam. Because the conditional statement in the try block evaluates to false. We therefore end up printing the statement that's contained in the else block. So hopefully you're starting to see how we can create user-defined exceptions, use them in our functions and our code, and then handle them accordingly. Having user-defined exceptions which make sense in the context of the program that you're designing makes it a lot easier for developers to trace back the errors and understand what's going wrong whenever development work is being done. So let's now do one more quick example. We'll create a new exception, so we'll put class, and we'll have this exception called score checker, and we have to once again inherit from the exception class. We'll then put def dunder init dunder, we'll pass in self, and we'll then pass in two more parameters, one called score and one called message. But for the message parameter, we'll default the argument to be you lost the game with an exclamation mark. I can then put self.score equals score to define the instance attribute score, and then I can put self.message equals message to include the instance attribute labeled message. Now underneath this I'm going to overwrite the dunder str dunder magic method and pass in the keyword self. And for this function I'm simply going to return a string which states you scored and then curly braces with an exclamation mark, then curly braces. I'm then going to use the .format method and pass in self.score, which refers to that instance attribute and the value that's passed in to the score parameter, and I'm then going to include self.message, which is the instance attribute's message that gets passed in. Otherwise it defaults to you lost the game. So let's now use this user-defined exception. If we create a variable called score and set this equal to an input function which asks enter your score with a colon and a space, and we'll once again wrap this in the built-in int function so we convert this into an integer, we can then put if not score is greater than 36. In other words, if we enter 36 or lower, then this will evaluate to true. Then we want to raise the score checker user defined exception and we will pass in the variable score. So if we run this code cell and first of all put 50, you can see that the code runs perfectly fine. We don't raise that score checker error. If I run this code cell for a second time and pass in the score 30, you can see that we run into a traceback, the score checker exception is raised, and we can see the message, you scored 30, you lost the game. So hopefully this is starting to make more sense in how we can create user-defined exceptions. We've learned how to create them and then handle them accordingly so our code continues running without running into those exceptions, which we know would cause the program to stop in its entirety. This may be your intention, but usually you'd want to handle these exceptions accordingly. In the next video, we're going to introduce a module known as Pylint, and this helps us write cleaner code. So I'll see you in the next video.